Hello students, welcome back to classes on computer organization. So let us see some concepts from basic processing units, that is module 5. Okay, so basic processing unit as per syllabus, this is module 5. So module 4 contents to be discussed that I shall consider that later. Okay, that is the arithmetic part. So some numerical things to be solved and some circuit design is there. So which I'll be considering at last. Okay. So, under the fundamental concepts, these are the things which we have discussed already, right, from module 1 to module 3. Okay, to execute an instruction, processor has to perform the following three steps they are saying. So, what are those three steps? The first step is fetching the content, right? Fetch contents of memory location pointed by PC. What is PC? PC is a program counter which will always points to a location. So this stores the address value and it acts as a pointer which points to the location of the operand where exactly the instruction is to be executed, right? The instructions are loaded into instruction register IR. So symbolically this is represented as, see, content of PC square bracket is written twice. Okay, because square bracket PC which represents the location, another square bracket represents the content from the location. Please try to understand. Square bracket, inside the square bracket if you write PC which will represent the location value or the address value. You are not looking for the location, now you are looking for the content. It's the content. Suppose your location is Karwar, so at Karwar you are finding something, say more mart, assume more mart you are finding at Karwar. So this PC represents Karwar, content of PC represents the more mart, isn't it? So that content of PC, again square bracket is written, that will be transferred to IR. This is what symbolically mentioned. Okay, then obviously for a sequential execution, the program counter is to be updated. It is to be updated by constant value, by adding constant value 4. So PC is updated by adding 4, PC plus 4. Okay, the third step is carry out the action specified the instruction by the instruction register. That's it. That is what execution phase is. Execute the instruction. Suppose if it is an addition, add instruction, that then go for addition. Suppose it is any other, it can be any other arithmetic or logical operation, do the same. Okay, the first two, you can see the three steps here. First two are called as fetch, collectively called as fetch phase. So what are the fetch phase actions then? Fetch phase actions are nothing but finding the contents from the program counter. First find out what is there at a program counter, right? Read the location, access the content from said location. That is what step number 1. Then step number 2, just go for incrementing the existing value of PC, right? By adding a constant value 4. So these two collectively called as fetch phase. And the third step is what? Since the instruction contents are loaded onto IR, take the necessary action, right? That is what IR is, instruction register is. Okay, then so step 3 is called as the execution phase. The operation specified by an instruction can be carried out by performing one or more of the following action. What are those then? See, again general scenario it is, read the content from the memory location and load it into a register. That is what step number 1. Read the data from one or more register, obviously. Perform an arithmetic or logical operation. Yeah, that depends on the type of the instruction what is used. Okay, and place the result into a register. Store the data from register into given memory location. What are registers then? Registers are nothing but memory uh, memory segments inside the processor. So memory unit, small memory unit inside the processor, and registers are used to store the temporary or intermediate results. Okay, If you want to store the results permanently, then it is to be copied onto the memory location. Memory location is different, since memory location is apart from the memory segment and register is apart from the processor segment. Please try to understand. These are the things we have studied right from module 1. In the first module itself, we have studied these things, right? So hardware components of the processor, you can see here in this diagram. The hardware component of the processor will be having uh, ALU and control unit. Apart from them, you can see the register file which contains the general purpose registers, memory units, whatever you call, and special purpose registers. Some of the registers are mentioned like IR, PC. Apart from them, we have MAR, MDR, right? Okay. So this you can recall the contents from module number 1, interrelationship between processor and memory, isn't it? So here this is the quick recall from module 1. The diagram is, so just observe this diagram carefully. Okay, the same contents like PC, MER, MDR, Y and all, it is mentioned along with or by considering the single bus architecture. Okay, let us see what it is. Yes, in this diagram you can see the single bus organization of data path inside the processor. So internal processor bus, the centralized line, the vertical line which is drawn at the center, which represents the internal processor bus. Single bus architecture, what it is, let us see. See, various components of the processor are listed here. You know, the different registers of the processor, some it has got some special purpose register and some general purpose register, right? So PC is one of the special purpose register. As you can see, the content of PC, it is bidirectional, it is shown as bidirectional. What is the meaning of bidirectional? Bidirectional means PC can send the data over onto the processor bus, or it can receive the data from the processor bus. That's it. What is MAR? MAR is memory address register. So see, one way communication, it can access the data from the internal processor bus and assign the address using address lines. But MDR is bidirectional bus, right? MDR is bidirectional bus, memory data register. The content, the actual contents are transferred using MDR. So bidirectional line you can see. Then Y and Z is there. What is Y? Yeah, Y and Z, they are called as the um, again special purpose registers, temporary registers from processor. Okay, temporary registers, again they are used to store the intermediate result computation. So Y is again it is taking the data from the internal processor bus. It is not, it is giving the data to the multiplexer. Please try to understand. Okay, what's the use of multiplexer and all? See, multiplexer means it takes the input from many sources and gives a single output, right? In order to update the program counter, this is required. In order to perform the arithmetic and logical operation, we have ALU. So in order to update the PC, we need to have a multiplexer where we are adding a constant value 4, okay, to the existing content. From where existing content is accessed? It is accessed from Y. So Y is unidirectional line. It is accessing the data from the internal processor bus, and it cannot directly give the data onto the bus. Instead, it gives the output to the multiplexer, and hence a constant value 4 will be added to it. Okay, then output will be given onto the ALU for performing the necessary operation. Then the result of ALU will be given to another register Z. Okay, once the result is computed, the result will be the output of Z. Please see the output of Z. Output of Z is connected to internal processor bus, right? Now see the right hand side of the diagram. uh, it has got another special purpose register, IR. What is IR? IR is instruction register, where instruction coding and decoding will be done by the another unit instruction decoder and control logic. Okay, again IR is taking the input from the internal processor bus and decoder and controller circuit. It will give the input to the decoder and control logic, so that will perform the necessary action and will be sending back the data to the internal processor bus. There are n number of general purpose registers apart from x, y and z. They are r0 to rn minus 1. Okay, r0 to rn minus 1, uh, as you can see, right? Again bidirectional arrow mark you can see, because it can take, either it can access the data or it can give the data onto the internal processor bus and hence onto the memory and so on, different units, peripherals, because the processor bus will be connected to the single bus. Recall the single bus architecture. It is connected to all the peripherals of the computer, like memory, input output devices and processor unit, right? Then we have another register, temporal register similar to x, y and z. We have one more register temp. Okay, its significance and all we'll be discussing. Okay, let us see the usage of them, how it works and all. Okay, in the next video. Thanks for watching. See you in my next video.